All right, let's get started. All right, let's get started. All right, so couple quick announcements. All right, everybody settle down, settle down. All right, so a couple quick announcements. First off, I went ahead and set my office hours. I'm going to go Monday, Tuesday, Wednesday, Thursday from 1 to 3, but I mean, I'm around, so it's not really that big of a deal. If y'all need me, you know where I'm at. The notes for today's lecture notes, or for today's lecture, are online. There's also an Excel file that we'll pull up just to give you all kind of an idea of what's going on with cost estimation. I don't know how heavy I'll get into it today, but it's there so that you all can sort of peruse it at your heart's content. When I pass the sign-in sheet around, I'm going to pass the sign-in sheet around, but I'm also going to pass this. This is called an RS Means Guide. Have you all ever used these before? Okay, I had a feeling that was the case. All right. When you look at it, it's going to look like just a massive table of numbers and data, because that's what it is. But I'm going to kind of remove a little bit of the mystery of it today and talk to you a little bit about cost estimation techniques, which regardless of what project that you're working on or what alternative that you pick, this is going to be something that applies to everybody in the room. So I'm going to pass the attendance sheet along with this. If you want, take a few moments and take a look at it. There's a few snippets in the lecture notes, so if you don't get a lot of time to look at it, it's no big deal because it's all here. One other point I will mention: these cost estimation guides are basically going to be they're going to be a very fundamental tool for how you all perform cost estimation for your projects. Okay, and I got a whole bunch of them on the cart outside my office. But what I don't want to have happen, especially at critical times, is if you have an alternatives report due March 9th and it's March 8th, and Team 2 just takes them all. So just you all are grown-ups. Just make sure that you're communicating. You use them, bring them back, etc. Also, these guides are hundreds of pages long, but you don't need the whole guide. You can very easily, turn to the data that you need, snap a few pictures, put it back, and then post those pictures to your group, Dropbox, GroupMe, whatever, and then now everybody has the data that you need. You don't actually need to take the books with you. So, but you all are grown-ups. I'll let you figure that out. There's a whole litany of them on the cart outside my office. One of the things you'll find with those cost estimation guides is they're all from different years, and that's a little bit by design, because that's one of the big things we're going to talk about today is cost indexing, how to bring all of your cost estimates to present location and present time, which is kind of a big concept in the world of cost estimation. Any questions so far? Okay. Quick question. I'm going to pause the video for a quick second. Okay. All right. So everybody good on your group names and who's the one in charge? Everybody good there? All right. Okay. So what we're going to do today is we're going to talk a little bit about cost estimation. I like to do this early because I've been doing the senior design stuff here at Marshall for a while now, and it's one of the things that I think Marshall students tend to have a little bit of weakness in. Like, they have a really good design and a really good project, and then the cost estimate is either way too low or way too high. And I kind of want to go through some fundamental cost estimation techniques with you, because I'm sure you all, I know you've had engineering econ and project management, but sometimes this stuff isn't really covered, and I want to try and talk about this so that you all can bring a little dose of reality into your cost estimates. So, all right. So, let's just sort of keep this simple and keep this at square one. Why is this stuff important? Why is it important to have an accurate cost estimation for a project? Well, in senior design, you all are going to, we're going to be looking at a civil engineering project, and you all are going to be developing alternative solutions to this project. And to keep it simple, like if we're talking about a building, you might have a steel building and then you might have a concrete building. Well, how do you know which one to pick? Well, it's a function of which one's more cost effective. If you don't have an accurate cost estimate, you can't make an accurate decision, okay? So that's sort of why we're talking about this. And this applies to whether you're doing a structures project, geotech, H&H, it doesn't matter. So That's why I wanted to take this discussion and start it first. So what we're going to do is we're going to talk a little bit about just the concept in general, talk about some of the resources that are available to you, like the RS Means Guide. And one of the big issues with cost estimates that we need to discuss is cost indexing. Have you all ever heard of cost indices before? You've heard that term? Okay. Don't worry, it's not complicated, but if you've never seen it before, it might look complicated. We'll look at a basic cost estimation and then look at one that's a little more detailed. The way that this cost estimation science works, I mean, you can keep it basic or you can get super detailed, I mean, down to estimating the taxes that each of your employees will have to pay on, like on their paychecks and whatnot. Like, it can get that detailed. So we can start at the 30,000 foot level and go down. But we'll try and take it easy and take it one step at a time. So let's talk about basic cost estimation, and let's talk about cost indexing. Okay, so it's one of the most fundamental aspects of a construction project is an estimate. I mean, the estimate forms the backbone of a bid. Without an accurate estimate, a contractor or an engineering firm or what have you is not going to win the bid for a given project. And if you're in the consultant world or if you're in the contracting world, if you're not winning bids, you're not getting work. Okay, so this is a very important concept that you need to understand. And basically what we're trying to do is do as much of a detailed breakdown of the project as possible, or as is necessary, in order to assess the feasibility of our design. And this can include quite a bit. I mean, we're not just talking about material, how much does the steel cost, how much does the concrete cost, the lumber, the bolts, all that. We're not talking about just that. We're talking about equipment costs. Do we have to rent a crane? Do we have to rent a dozer? Maintenance on that equipment, etc. A big aspect of a construction project is obviously labor. How many labor resources do you need? How many labor hours? In order to use the term man hours anymore, we use labor hours. How many labor hours goes into a given project? Engineering costs. I mean, it's not just the construction workers, it's also us actually putting in the work to design the project. So support personnel costs, office personnel costs, overhead costs, operating expenses costs, and then profit too. If the project realistically costs $100,000 to build, the bid is going to be a little more because there has to be some profit. I mean, there is sort of a point to this, in regards to making money. So I want you to kind of get an idea that a cost estimate needs to be pretty accurate, and it can also be fairly detailed and fairly intricate. Now, by and large, the absolute best resource for a cost estimate in the real world is your firm, is your company. Okay. A lot of what ends up happening more often than not is, if you go to an engineering firm that's been practicing, like let's say you all get a job when you get out of here and you work for a firm like Baker or something, and Baker's been operating for decades and whatnot in the area. Well, I mean, if they are designing highway bridges all day every day, well, they're going to have a really good idea, right off the bat, how much a given project's going to cost, because they do this every day. They're going to have the most accurate data on unit costs and on project costs because they've done similar projects before. So I want that to be a very important sticking point before we even get into any of this, is that the resources that we're using, like RS Means and estimation software and supplier catalogs, etc. I mean, I really think that stuff is kind of secondary to what is the most valuable piece of information, is that what you get from your colleagues at your firm. So I really want that to settle in. Now, we're in an academics setting, so we don't have an engineering firm to go off of. So I want you to have a little bit of experience with some of these resources like supplier catalogs, and particularly RS Mean guides. I mean, even if you're using data from, let's say, your colleagues at an engineering firm or the DOH or et cetera, the cost data that you're going to get is going to be in a format very similar to this. So I want you to kind of have an understanding as to how this stuff works. Now, I mentioned this term RS Means. RS Means is basically, their main job is to provide cost data on construction. Like, that's what they do. They are a very fundamental civil engineering resource. They are used quite readily. You can go to their website. They have unit costs for various components, and it's not just materials, it's labor, it's equipment, it's crew productivity, the whole 9 yards. And they release these guides very regularly and edit these costs based on data that gets reported back to them from contractors, from consultants, from developers and what have you. So this data is pretty real world. It's pretty representative of what you're going to get in the real world. So I don't want you to think that this stuff isn't accurate. This is sort of the standard. Okay. So the website, you can see the website there, and you all can visit that to your heart's content. There are some resources in this presentation that are online that are going to make your lives a little easier. Some of them are PDFs, and after this, you should probably download those and just have them on hand. But I want to keep it basic, and I want to get into how you actually perform a cost estimate. So we're going to start off really, really simple, and then we're going to take this cost estimate and we're going to adjust it for a little bit of reality. Okay? So to start off, one of those fundamental equations that you'll ever use in cost estimation is the unit price equation. So the idea is, if I have some component that costs so many dollars per foot, or so many dollars per square foot, or so many dollars per cubic yard, I take that unit price or that unit cost, multiply it by the number of units, and that's the cost. It's that simple. Okay? So if I have a W10 by 49, let's say that W10 by 49 is $60 per LF. What's LF stand for? Linear feet. Okay. So if I have a W10 by 49, it costs $60 per linear foot, and that W10 by 49 is 12 foot long. How much does it cost? $720. That's pretty simple, right? I don't think that's that complicated. Okay. If you understand that, I think that's part one, and I think that's pretty easy to take in. Okay. This is an example of some data that you would get from RS Means, to where you would look up some of these unit costs. We'll dig into this a little bit more later, but the data can get pretty intricate. So for instance, you all see that guide that's been passed around. I don't know where it's back there. You probably, when you were flipping through the guide, you saw a lot of tables like this. The guide is basically split up into different materials. So there's a section on concrete, there's a section on metals, there's a section on aluminum. I have some site work guides up on the cart that have unit costs on earthwork, etc. So for instance, if you're looking at concrete masonry units, so basically like cinder blocks, okay? So if you're looking at concrete masonry units, looking at backup, depending upon how thick that is, so for instance, your 2007 bare cost, the material cost, $1.98, $2.15, $2.87. Now, what do these costs mean? Well, this is $2.87 per SF, per square foot. Okay. So we have material costs, we have labor costs. So this is total cost. We really don't need any equipment if you're just laying block. Total cost, including overhead and profit. So we'll talk about that in a little more specificity here in a little bit. There's also some information on crews. So if you notice here, this says crew D-8. If you go to the back of the RS Mean guides, there are various work crews listed, and those work crews are associated with the jobs that are being done. So for instance, you would have a different work crew, let's say for earthwork, than you would for, say, ironworking. You'd have steel workers, and you'd have erection cranes and what have you for iron workers. But for if we're talking about, let's say, earthwork, you're going to have dozers and front end loaders, etc. So the work crews that are in the back are representative of the work that's being done. So, and for each of those work crews, we have how many, what's the daily output of those work crews, how many labor hours it takes to produce, a given unit of work, etc. And we'll dig into how we can use those to estimate material costs, labor costs, equipment costs, etc. It's not that difficult if you just take your time with it. Now, the data here is listed in terms of square feet. One thing I will mention is a lot of the units are pretty simple. Okay, a lot of them are pretty basic. Some of them, I mean, even I'm like, well, what the heck does that mean? There's a lot of like AFUE. Like, what the heck does that stand for? Annual fuel utilization efficiency. So I wouldn't remember that. There's no way I'd remember that. There's a link here that will take you to a PDF that will actually list what each of those units are. Now, I'll be honest, you should know that LF stands for linear feet. You should know that SF stands for square foot. You should know that CY stands for cubic. There we go. Okay. So you should know some fundamental basic ones, but I just prepare you that it's very possible that there are some that you might not have seen before. So, so there you go. So you all can download that and have that handy. Okay. Now, that's great and everything, but we have to talk a little bit about cost indexing. Okay, so let me explain cost indexing in a nutshell. Has anybody ever heard the term consumer price index? Have you ever heard that term before? Okay, does anybody know what that is? Okay, all right. It sounds complicated, right? Okay, let's keep it simple. Has anybody from an, let's say an earlier generation ever come up to you and said something to the tune of, well, back in my day, a Coke cost a nickel? Have you ever heard something like that said to you before? Okay. Over time, the purchasing power of the U.S. dollar tends to decrease, right? If back in the 50s and 60s and 70s, like a can of Coca-Cola cost, maybe a nickel or a dime or a quarter, and nowadays it's much more expensive, that's because of inflation and the purchasing power of the dollar. Over time, that goes down. So if you want to know what a consumer price index is, a consumer price index is basically a dimensionless number that will sort of express to you how expensive goods are now versus an earlier point in time. Okay. The reason why that's important for us here is because who's got the guide? Who's got the guide? Do you have it? What year does that come from? 2011, okay? So that cost data is good, accurate data. The problem is that data is from 2011, okay? It's not 2011, it's 2018. So we need to adjust all of those dollar figures that are listed in that guide to 2018 dollars. And that might not seem like a big jump. If you've got a $50 million construction project, that is a big deal, okay? I mean, $1 or $2 million on a $50 million project might not seem like a big deal, but that might be your profit margin, okay? That might be the difference between whether or not you get that bid or not. This is really kind of important stuff, so it's something to keep in mind. So there are two sort of cost indices or cost index adjustments that we will need to perform to all of our cost estimates. The first one is a function of time, okay? So basically, a cost index is a ratio of the cost of goods from one period to another. So the first thing that we'll do is a function of time. So the way it works, you basically have costs that are reported in this guide, let's say from 2011. You would divide those by the cost index for 2011 and multiply it by the cost index for, say, 2018, and bam, there's your current data. So to give you kind of an idea, I have here cost indices from this table is reported based on 2016. If you click this link, it'll give you the data for 2018, so it's much more accurate. But to give you kind of an idea, let's say I'm using an RS means guide from 1985, okay? So I go to my cost index, my historical cost index table, and I say, okay, for 1985, the cost index based on 2016, we'll say is like 39.9, okay? And since this is based off 2016, the cost index for 2016 is 100, okay? So your reference year is always 100. So to give you kind of an idea, let me see if my pen's working. Okay, all right. So if I had something that costs, let's say 1985, let's say something costs $50 in 2016, the idea is that it would cost $50 times 100 over 39.9. Does that make sense? Now, if you want, you could use the 100 and the 39.9, or you could use the 207 and the 82.6. The guides will give you two frames of reference. One is the current date or the current year, so the one that you download will give you a reference based off of January 1st, 2018. The other is a reference date of January 1st, 1993. That's just sort of a standard date that all the RS mean guides tend to employ. You can use either one. It's not going to matter, because if you take 100 and divide it by 39.9 or 207.2 and divide it by 82.6, it comes out to the same. I mean, plus or minus rounding and whatnot. So just curious, anybody has a calculator, like what does that come out to be? About $125. So something that cost 50 bucks back in the mid-'80s costs about $125 today. And that doesn't seem like it's that far off. That sounds like a pretty reasonable estimate, right? So that'll give you kind of an idea of what's going on. So depending upon the RS mean guides that you're using, you will need to take those dollars and adjust them to the current date. Does that make sense? Okay with that? All right. So now that's part one of the issue. The other part of the issue is the location, okay? The data that is reported in RS means reported based off of a national average, okay? And that national average is basically taking costs in these 30 cities and averaging them. So costs from data in like Atlanta and Baltimore and Boston and Buffalo, etc. We are not in Buffalo, New York. We're in Huntington, West Virginia, okay? So something that costs X number of dollars in Dallas or Detroit or San Diego is not going to have the same cost here in Huntington, West Virginia. So not only are we going to need to adjust costs based off of time, we're going to need to adjust them based off of location, okay? Very similarly, it's a similar ratio. Divide by the cost index for America, multiply it by the cost index for your given city, and there you go. Okay, and if you go to the RS mean guides in the back, and there's also a link to download these as well, the link is from the location indices in 2013, but it really doesn't matter because you're dealing with time using historical indices. City cost indices, the time is fixed, and it's really more about location. So if you look at city cost indices, you'll see that they're listed. We have our national average, and you notice the national average are all listed as 100s. Yes.
Can you go back to the last slide?
Yes.
It has the top 30 major cities. What would we use? Columbus being the closest to us?
No. What I'm saying is, so here's what I'm getting at. That's a good question. So the question was, and I'm going to try and repeat it for the recording, do you use the closest city? Not from a national average standpoint, but you would from a city cost index standpoint. And just give me a sec to explain. Okay, so all of the data that is reported in any of these RS mean guides comes from construction data that's been averaged for these 30 cities. Okay, so anything that you look up in the bulk of that report, so like any of this stuff, like your bare unit cost for concrete blocks or steel columns or bolts, etc., all come from just from an average from these 30 cities. Okay, we are not in these 30 cities. We're in Huntington. Okay, so what we're going to do is go to the back and look up the cost index for Huntington. And believe it or not, I mean there are cost indices. I mean there are cost indices galore for a multitude of different locations and cities within the U.S. Like West Virginia alone has, I think, maybe 12 different locations that are listed. There's like Bluefield, Beckley. This table's listing Gasaway, Huntington, Lewisburg, Martinsburg, Morgantown, etc. Now, if you were like nowhere near these cities, if you were in the middle of nowhere in West Virginia, you would just pick the closest one that you can. Luckily, we're in Huntington, so we're looking at Huntington. So we have material costs, installation costs, and total costs dependent upon what we're looking at. So we've got contractor equipment, we've got site and infrastructure demolition, we've got concrete, masonry, metals, etc. So if we were looking at metals, our material costs for metals tend to be a little cheaper, whereas cast-in-place concrete tends to be a little more expensive. Do you see what I mean? It just depends on what you're looking at. And again, the United States is always sort of 100. So if it's higher than 100, it's more expensive. If it's less than 100, it's less expensive. That makes sense? So let's go back to this. I'm gonna go back a few slides. Remember this? Remember how much does 12 linear foot of W10 by 49 cost at $60 per foot? Let's say that that's $60 per foot came from an RS means guide that I pulled in 1985, okay? And I need to convert that to 2016 dollars, okay? So I can do the unit cost equation to say, all right, $60 per foot for 12 feet is $720, but I need to take that $720, I need to bring it back to a current date. Let's say it's 2016. I need to bring it back to a current date. And then I also need to bring those costs to Huntington, West Virginia, okay? So to determine my actual costs, I'd say, all right, let's take that $720. Let's first off adjust it by 100 divided by 39.9 to bring it to 2016. And let's also adjust it by 97.8 divided by 100 to bring it to Huntington, West Virginia. So that's $720 in 1985 in, an average American city. In 2016 in Huntington is actually around $1,764.81. Does that make sense? Everybody okay with that? Any questions? Okay. Now, before we end and get to a little bit more of a detailed example, just to dig into this a little bit, you all are going to be estimating projects that might be $50 million. What I do not want to see is a cost estimate in your presentation that, okay, here's our project, and we estimate that it costs $52,946,852.27. You're not that good, okay? You're just not that good. I'm not that good. Nobody's that good, okay? I fully understand that Microsoft Excel just does the math for you and that it'll just keep everything, it'll track all your decimals and it'll give you everything to the nearest fraction of a penny. But you can't make a real decision based on that, okay? And you do not have enough certainty in that cost estimate. You're just not certain, okay? So the point that I'm mentioning is that, that's $720 in 1985. If I do the math, it's $1,764.81, okay? Now, if I go and call Huntington Steel and say, I want to buy 12 feet of a W10 by 49, it better cost $1,764.81. They're going to go, well, let's see how much it costs. It's probably going to be close. It's probably not going to be exact. You see what I mean? So my point is, when you're expressing these cost estimates, be reasonable with it. Round your values off to something that makes sense. Like for instance, this is a guide over here on the right. So if you have a project that's going to be anywhere between, let's say, a $10,000 project and a $50,000 project. Let's say you're doing some major renovations or construction near your house, something that's major, something, $10,000, $20,000 project. If you get an estimate for the work on that project, you can't expect that estimate is accurate to the penny. But you can probably expect that it's accurate to, let's say, within $100. When you're talking about a project that's anywhere between $10,000 and $50,000, I think it's reasonable to assume that estimate be accurate to within, let's say, $100. So, if it's plus or minus $20, $50, that's pretty good, okay? So you notice, like, the rounding of costs, it's a function of the size of the project. Like, if you've got a project that's, $50 million, don't express the cost to the nearest penny. You're not that good, okay? That make sense? Any questions? So this is just give you kind of an idea. If it's $1,764, I'd probably send something like $1,775 or maybe even $1,800. So, yes?
Would you round each individual item or just the entire estimate?
That's a good question. Depending upon how intricate my cost estimate is, I might actually round each item. It depends. If I'm only estimating like 3 or 4 items, that's one thing. If I've got 600 items, that might be a little different. It would just depend. I would just use some engineering judgment and use some common sense. Another point I would also mention, and this is something that I completely haven't talked about, have you all ever heard the term of a waste factor before? Okay, so if you haven't, just so everybody's clear, let's say that I'm casting a driveway out of concrete, okay? Now I can do length times width times thickness to determine a volume of concrete, and let's say that it's I don't know, 15 cubic yards. Do I order 15 cubic yards of concrete? No, I order like 16 or 17 cubic yards because, you know, some might not get consolidated, some might get stuck inside the truck, you know, et cetera. Some might get spilled. So, you know, you also need to include that in your estimates as well. Even if, you know, you've got everything accurate down to the, you know, every single bolt and every single washer in a 30-story building. I mean, throw some waste factor in there, throw some conservatism in there to ensure that you're not underestimating the project. You'd rather slightly overestimate than you would underestimate, because if you underestimate and then you got to throw a change order into the mix, nobody likes change orders. Well, contractors love them, but engineers don't. So, any questions? Yes.
Like 5 or 10%, like waste care procedure?
That's a good question. So the question is, how much waste factor should you use? I mean, 5 to 10% is pretty reasonable. I would also say that there really isn't a hard and fast rule. There is something to be said about using engineering judgment on the project that you're working on. For instance, I wonder if you would use the same waste factor on a driveway in your backyard versus a dam. See what I mean? Yeah. And it's one of those things where I'm almost purposely being a little tight-lipped and, you know, letting you use a little bit of judgment on it. Does that make sense? These are good questions. These are really good questions. Anything else? Okay. I do want to bring up some, just some, little bit more of a detailed cost estimate, which, by the way, this Excel file is on your Blackboard page, so you all can download this to your heart's content. This data that you see right here in this table, it comes from the RS Means Guide that just got passed around. This is one of the work crews that's listed in the back. So if you recall from the concrete masonry unit listing in RS Means, there was like a crew, what was it, D8? Is that what it said? D8. This is crew E2. This is a structural steel crew, okay? So we have one foreman, we have 4 structural steel workers, we have an equipment operator, a maintenance personnel, and then we also have the crane itself. This is a 90-ton crane. So right off the bat, if you were doing an estimate on, let's say, a 150-foot, you know, highway bridge or something, maybe the crane isn't adequately sized. Maybe you got to bump the crane up a little bit because your pieces are a little heavier. Maybe not. I don't know. I'm just saying, you know, you need to think broadly about this stuff. Okay. So we have bare costs. This is cost per hour per LH. What's LH stand for? Labor hour. Yeah, everything's listed in labor hour. So we have bare cost. We have including overhead and profit, and so on and so forth. Now, I'm mentioning this crew data here because I want to look at this. Okay. This data that you see here in this region comes from the main body of the report, and this is basically typing out the data that you would get for a 14 by 74 column. So this is like, if you go to that RS Means Guide and look up in section 5, the W14 by 74 column, that's the unit cost, the daily output, the labor hours, so on and so forth. So the idea is that crew should be able to put out 984 linear feet of column per day. It takes 0.057 labor hours to produce 1 foot of that column. The material cost per linear foot, the labor cost per linear foot, the equipment cost per linear foot, etc. So if I was doing, let's say I was doing a 24-foot column with an overhead rate of 10%, I could just use these costs directly. I could use these costs directly. Let me zoom in a little bit. I could use these costs directly and get a total cost of about $2,500. If I used the more accurate labor data from over here, the cost tends to bump up a little bit, but not terribly. Again, you got to think of this relatively. So if I were to use, let's say, this, you're talking about 2,530. Oh, goodness. let me do this. There we go. If you were to adjust this labor cost based off of just what's listed in the main body of the report, you're talking about $2,530 versus $2,570 or $2,580. Doesn't really change your cost estimate all that much, but because you're accounting for that crude data, you get a little more accuracy. See, one of the things with RS means is you could just straight go to your crew data and say, well, it costs this many it costs this many dollars per labor hour, multiply that by the number of labor hours, and boom, there's your cost. Or you can get super, super detailed. You can even go into the labor costs and say, okay, how much does each labor hour cost? How much are we going to have to put into their retirement? How much do we have to put into their health insurance? I mean, you can get that detailed with this stuff. I'm not going to expect you to get that detailed. What I'm saying is, the more detailed, the better. And the more experience you get with this stuff, the better. I don't want it to overwhelm you, but I want to expose you to it on day one so that you're aware when it comes to like March 9th or something, and you go, oh God, there's a cost estimate. No. You want to be working on that as soon as you can. Yes, sir?
So are the overhead rates for each item?
The overhead and profit, yeah.
So like for our costs for the crew E2, that includes OPR.
Yeah.
Do you also incorporate that into
Let-
the total overhead rate?
That's good. Let me explain why the guide lists that listed. Okay, it's really because of profit. It's not really so much because of the overhead. The RS means guide assumes a standard profit rate of 10%. Okay, if you wanted to assume a profit rate of 15% or 5%, then you would need to take bare costs and then go and do more math. But if you want to just use a blanket profit of 10%, then you've got the data there. Do you see what I mean? So that's why you see, that's why it looks more complicated than it really is, because you've got bare costs and you've got including overhead and profit. You're like, well, which one do I use? Well, it depends on your profit rate. Like if you were using 10% profit like the RS means guide is, just go with the total cost. You see what I mean? So, and let me also say this, just so everybody's aware. Remember, your alternatives calculations and your alternatives assessment can be rough. It can be fundamental. It can be basic, okay? I'm more concerned that your detailed cost estimate and your in-depth assessment is done for the final stage. And your draft final report isn't due till, what, April 13th or something like that? I'm fully aware that from now till March 9th, you may have just some basic unit costs and basic indexing, and bam, here's a price for the price for the project. Heck, it gets even better. You can go into the RS mean guides, and it'll just give you cost per square foot of an office building. So just take the square foot. There's your building. You know what I mean? So I don't want you to get worried. Okay. This is what my main concern is. I want you to have clearly stated assumptions, clearly followable calculations, and a clearly defined logic for why you chose alternative 1 versus alternative 2. And it's got to be defendable, okay? On that, sky's the limit. Crickets. Any questions? Okay. All of these files and whatnot are on Blackboard, so you all can peruse those and examine those to your heart's content. So you've got plenty of time to investigate that. Yes, sir?
Can you go back to where you were switching between costs?
Yes.
Sure where you got the first one you were using?
Okay.
So the lower cost?
Okay. So the lower cost. Okay. Let me go back to this. The lower cost was basically coming from this, but it was coming from this for the W14 by 74, because more representative of that. If you want to be more conservative, and this 458, like where's this 458 come from? The 458 comes from basically taking the cost per labor hour and multiplying it by the productivity rate to get a more accurate cost per hour for that crew. Now that cost, you are sort of double counting your overhead a little bit, your overhead and profit a little bit, but the way it washes out, I sort of go ahead and leave it in there because the estimate ends up being a little more conservative. Again, I'd rather slightly overestimate than underestimate. Does that make sense? Okay, so who's got the RS Meets guide? Thank you. All right. So, and I threw some sticky notes in here, and I'll probably leave this up here up front so that you all can take a look at it. Okay. If you go to this right here, okay, Section 4 of the cost of RS Means deals with concrete. Section 5 deals with metals, okay? If you go to Section 5, okay, so this is Section 5, and you go to the section on structural steel framing, so that all this stuff here is on structural steel framing, and you go to structural steel columns, and you go down, you can see the cost listing for a W14 by 74. And all this data, just copy and paste it right from there. Yes. It was from either one of two places. It was from either the actual material cost for a W14 by 74, or it was from the back where, give me a sec. Oh, I have it marked. Where all the work crews are listed. So this was crew E2 because E2 is a steel crew. That's for the column. Yes.
So when you're doing your cost estimation, you can use either or. You can either go to the listings in the back to get your cost, or do it individually by.
Yes, and another thing to point out, so I would sort of characterize that as sort of like a level 1 estimate versus a level 2 estimate. Like level 1, just using the bare costs here. Level 2, trying to get more in depth with the crews. Level 3 is to take those crews and actually start looking at West Virginia labor rates and looking at West Virginia benefits and an example, which by the way is in here. You can even get that detailed. So yeah. This is a very valuable and useful guide. I mean, even firms that have all that data, they probably have a few of these on file. So, any questions? All right. What I'm going to do, I'm probably just going to leave this like up here, and then you all can sort of take a look at it. Remember, there are boatloads of these on the card outside my office. Again, just be respectful. Don't just take them all. You will have some angry groups on your hands. And then there'll be a mutiny. I don't want that. All right. That's all I got. I will see you all on Friday. Friday, we'll talk about some specifics on reporting guidelines, on format, meeting minutes, timesheets, all that, and we'll get into it. That's all I got. I'll see you all on Friday.